Number 3, here's an idea. What if you were to actually make a prediction with your model? Like any prediction. You know, those things that you have to do in science for it to be science?
Sorry, that is nothing but smack talk and is utterly false. There isn't a single definition that says a prediction is a requirement to be considered science. Science is systematized knowledge in general. With that being the case, I could simply document what mice do and do not eat in an organized fashion, and that would be considered science. No predictions necessary. Nonetheless, we make several predictions throughout our series, and recently, on our community tab, we invited people to make their very own flat Earth model prediction. Here I asked, if you were to stand on the right side of the 2 fish tanks and look toward the light, would you see the source of the light? Yes or no? Explain your reasoning. And then in the comments section I specified that is looking through the water, not above it. It is a simple invitation, but nonetheless, even this has had its criticisms. One particular person seemed pretty offended when he complained, saying that this isn't a prediction, it's a hypothesis. For anyone who might feel similarly, I advise you to consult with your dictionary. To predict simply means to declare or tell something in advance. With that being the case, I can accurately say I can predict how this video is going to end. And that can be considered a self-fulfilling prophecy. Nonetheless, it would still be accurately described as a prediction. Some people make words out to be more than they actually are. The word professor is another example of this. And then when I treat it as it is, over what people make it out to be, that can offend some people. If you are one of those people who are offended, I'm sorry about that. But I am one of those people who likes to view the world as it is, not as people make it out to be. Alright, so the word hypothesis merely means an assumption or guess, or even an educated guess. So looking back on our invitation, we can accurately describe people's guesses as hypotheses. However, when a hypothesis holds true and someone guessed right, that is when their hypothesis can accurately be described as a prediction, because it accurately declared in advance what was going to happen. Alright, now let's take a look at some of the responses we got here. Kevin says, refraction will prevent you from seeing the source of the light because the refracted light will bend downwards from looking through the water from the fish tank. And similarly, Ralph says, no, you would not see the source of the light. On our debate board, Vimal expressed similar views. He said that in the case of the laser, you wouldn't be able to see the source of the light. But in the case of normal light, you would, which is why you were able to see the boat from across the 2 fish tanks. Jeffrey also said that he didn't think I would be able to see the source of the light, unless possibly it was in the reflection at the top of the water of the tank. Now I really like this part. He says, I think you'll see the ground of the tank illuminated green by the diffuse laser light, but that's not seeing the light source itself. I really appreciate that inclusion, also predicting what he would see on the ground, because that was one of my major curiosities when I started this project. I wanted to know if the laser light touches the ground before it reaches you, would you still be able to see it? And that was one of the reasons why I put washcloths on the bottom, to help absorb the light. Now if you look closely to the far end over here, there is some light reaching it. But it is really dim, and that is what Jeff is basing his hypothesis on. You would be able to see the laser hit the bottom of the tank, but it's going to be really diffuse. Now let's go do our big reveal, and then I'll talk about what my prediction was after. Alright, here we're going to start with our laser reaching the very end of the tank, and then we're going to bring it forward so we can see the different perspectives. Alright, here we are at the very end of the tank. We can see that whole laser going all the way back. You can kind of see it touching the ground there, though it's not very strong. I'll let you judge for yourself whether your hypothesis was right or wrong. I think the important thing that we ask ourselves is what can we learn from this? And how does this pertain to the flat Earth? Sorry, the beam is kind of hard to see with all the lights on, so we'll turn them off in a moment and we'll show you this in the dark. Alright, so this time we are switching places and putting the laser on the other end of the tank. Alright, there's our laser. And we are going to move it over to the right a little bit so we can get a better view of it. Now we are going to slide the laser down the glass to get more refraction. We're not tilting this at all, just sliding it down the glass. And for some reason, our point of origin doesn't appear to be moving up and down. I think that's really interesting. Alright, now we're going to slide it all the way down. Look at that. Now we can no longer see the beam, but just see the source point. Now, I'm curious if we could refract this to the point that we could no longer see the laser at all. But in order to do that, I think we're going to have to use a much bigger tank. We'll have to come back to this and try this again in the future. Alright, now let me share with you what my prediction was. Way back in February of 2020, long before I had even thought of doing this laser experiment, I produced a video entitled Dawn. In this lesson, we talked about how the light touches the mountaintops first at sunrise. And based on the known principles of refraction and reflection, we formed the hypothesis that even when all of the direct light was touching the ground in front of you, you would still be able to see the sun due to atmospheric reflection. So with that being the case, our laser experiment confirms our hypothesis as a plausible prediction and further grounds it in observation and experimentation. Now, I know the sun isn't a laser, and I don't claim it is one. Here the laser just represents the farthest reaching direct sunlight on the terminator line between night and day. And since this whole concept matches this whole concept, I claim another victory for the flat Earth. All that is left now to further prove our hypothesis is for me to pull out a bigger tank so we can make that light go completely out of view. Rest assured, I look forward to that. Until then, thank you for watching.